Shake Table Lab by Henry Hansen and Katrina Blackman. The first thing that we did was brainstorm our ideas on how we wanted our tower to look like. The building code required us to have 2 floors that are both 18 centimeters or higher. The first day of construction, we worked on the frame of our tower. The first thing that we started with was making 4 double straws and taping them to the base. We then started to work on the boxes of our tower. The next thing that we did was work on triangle supports. We chose to make triangle ones because they made the tower sturdy and it took less straws than doing cross supports. Henry and I did this on both floors all the way around. We then started to work on the top of our tower. Straw supports in the center of the tower will make the floors more sturdy for when sandbags are going to be placed. The last thing that we did was color and tape. Doing this would make the tape blend in with the straws. We also added a flag onto our tower to add some color. This is how our tower looked when it was finished. The height of our tower, 61 centimeters, is much taller than the 36 centimeters that we anticipated on. So much changed from our building sketch to the final product. A static test is a test of the tower with sandbags on when it is not being shaken. The static test helped us make sure that our tower was going to be strong and sturdy for the actual test. To add strength to our tower, we added triple straws to the bottom of our tower. These straws would make the structure more secure for when it would be shaken. One of the tower's strongest parts is where the 3 parts of the triangle connect. The frame is supported from a straw going straight up and 2 straws going diagonal away from each other. One of the weakest parts of our tower is the lonely straws that just go straight up. These straws don't have any support supported on it, so the straw can just snap. Our tower has a lot of tape, in some places more than others. The tape helped us connect the straws and paper together. It was a key part in our tower. One of our extra supplies was construction paper. We used the construction paper to make the floors of our tower and to make the flag. Our tower is being shaken by 8 sandbags in this video. This is almost halfway through our shaking process of our tower.
Oh no, it's flexing.
Dang it!
How much is that? Is it 10? 10.
It's a 9! All of the weight of the 14 sandbags finally collapsed the tower.
Oh no. Oh no. Oh no.
You're gonna tie with us.
The XYZ graph shows how much the tower moved side to side, forward and backward, and up and down. The shaking was recorded from a small box that connected to a computer. We could tell that the tower moved side to side the most from this graph.
Our tower successfully held 12 sandbags and it collapsed on the 14th sandbag. Our tower failed near the bottom where one of our supports came loose due to loose tape. We could have strengthened our tower by strengthening the tape and adding more supports. I learned that there are a lot of things to consider when building an earthquake-proof building, and that I had a lot of fun collapsing the tower.
Our tower successfully held 12 sandbags and collapsed on the 14th. Our building failed in one of the supporting corners. The corner didn't have enough tape or supports attached to it. With the wobbly corner, the tower gave in. Some changes that I would have liked to make to our tower would have been to add more tape. When watching our tower shake, I could see tape lifting off of the base and start to fall apart. If we added more tape, this would have not have happened. I learned that you have to have a lot of supports on your tower and that building designs can change completely. I enjoyed being able to create something and then demolish it. Also, I really liked being able to communicate with someone and make a great project.